Okay, so in this question is telling us that the student is using this apparatus to investigate the pressure and volume inside a gas syringe. So it's just putting weights on this platform and is pushing the plunger of the syringe down, and the volume changes. And the student is taking the values of the volume and the pressure, of course, while is loading the weights and then when is unloading the weights. The table of the results is that there's a missing value that we have to find out, and we can find out this value using the average value of volume that is given there. So we're looking at a number that when is added to 90 and divide by 2, this is how we find the average. We add and we divide by 2 if it's two values that we're using. So we're looking something that gives us the average of 92. So that will be 94. And the second part is asking us to suggest why the student takes reading for both increasing the pressure when it's adding weights and decreasing the pressure when it's removing the weights, when it's unloading. So there's a few reasons for that. So this question is for 2 points, so only 2 of these statements would be enough to get the points, to get the marks. So I'm just going to discuss a few other options as well. So we have 2 sets of data. So one for unloading, one for loading. And by repeating an investigation in general, that will always give us more reliable results. So instead of having only 1 set of data, now we have 2. Automatically this makes the investigation more reliable. And it gives us the chance to find the average. Again, this is kind of linked to reliability, to get more measurements, repeat the experiment and find the average. If we have more than 1 set of data, we can identify any anomalous results, meaning results that they don't fit the pattern. As you can see in this table, both of the results every time are kind of similar to each other. But if, for example, you had something which was 135, this, you can see that it doesn't kind of really fit the pattern, so we can consider this as an anomaly, an anomalous result. But in that case, we don't have any anomalous results. The anomalous results are, of course, related to reliability as well. And now, the next 2 statements about temperature and friction. Now, this is changes of pressure and volume. And if you remember, this is about the Boyle's law that says pressure 1, volume 1 equals pressure 2, volume 2, or any other changes would always be constant. In order for Boyle's law to apply, we have to have the temperature to be constant. And because of friction between the piston here and the walls of the syringe, because of that friction, we know that friction is causing changes in the temperature. Therefore, we might have some temperature changes. So by having more than 1 measurement, we can see whether there's any effect of the temperature or the friction. So the last 2 statements has to do with temperature and friction. The next question, the student is plotting the graph of the pressure and the average volume. So the results from the table is presenting them in a graph. And you can see that on this graph, it doesn't start from 0, but it starts from 40. So it kind of skips the values from 0 to 40. And it's asking us to suggest reason why we don't start from 0. If you see from the results here, the lowest value for pressure is 50, the lowest value for volume is also 50, so there's no values below that. So no need to include that part of the graph if there's not going to be any data on that. So starting from 40 is because the lowest values for pressure and volume is 50, and in reality, can the volume be 0? No, the air that is inside the syringe, the particles, they always have some volume. It's not possible to take volume to 0. So it doesn't make sense to have any values near 0. And next question is quite interesting. So the student has drawn both a straight line of best fit and a curve of best fit, and we need to discuss which line is correct. Now, in this case, both lines can be correct. Why? Because if we start by looking at the straight line, you can see it's kind of an average line. And what makes it average? Because you have a couple of points above the line, you have a couple of points below the line, and then you have 2 points that are exactly on the line. So the straight line, as I have written there, the straight line is having an even distribution of the points about the line. So it's correct to do that. Now, if we're looking at the curve, you can see that most of the points are actually on the curve. So the curve includes all the points. So this is also correct. Now, I have added a couple of graphs here just to explain this a bit more. If the trend that we can see on the results is obviously a curve, like in this case, then there's no point of trying to do a graph, to do a line, sorry. It doesn't, the line, the blue line doesn't really show the pattern or the trend of the points. So sometimes it's obviously that the pattern should be a curve. In our case, it's not that clear. It could have been both. So, like this example. This example can be described either as a curve or as a line. But the line has to be an average. If I draw a line like that most of the points are below the line and then only 1 or 2 are on the line, this is not the average line. Same if I do something like that. You see, I'm including a couple of points on the line and everything else is above. The right way to do that is to draw an average line like the student did on this graph. So if I do something like that, I have 2 points above the line, 2 points below the line, and 1 point on the line. So it's kind of an even distribution of the points. The next question is, how do we make this a fair test? So remember, a fair test is when I keep everything the same except the 2 variables that I'm trying to investigate. So in this case, we're investigating the relation between pressure and volume. So these are the only things that are changing. And everything else has to be kept the same. So for Boyle's law, remember that temperature has to be constant. So this is the first thing we have to write. And also the other thing that has to be kept the same is the mass or the number of the particles of the gas. So we have to keep the mass the same, or we shouldn't allow any air to get in or air to go out because this will affect the mass. And because we have this friction on the syringe, and this friction might result in changing the temperature, so sometimes it's better if we allow some time between taking different readings. So we add the mass, the pressure changes, and then we allow some time until it returns to the room temperature, just to make sure that we maintain the temperature constant. Next question is to suggest 2 ways that we can improve the quality of the data that we have collected. And a few possible options for this is to increase the resolution of the instrument. Now, the resolution of the instrument is the smallest thing the instrument can measure. So if we use equipment that is more precise, that it gives us measurements of more decimals, that will give us more accurate results, and therefore it improves the quality of the data. And another thing we can do, if you have a look at the graph, you see that there are some data here, some data there, but then on the middle, we don't have any measurements. So one way to improve this is to taking measurements on this range, but there's no data. And also, we can always increase the range of the data. So instead of having 50 to, let's say, 100, we can have measurements above 100 or kind of below below 50. So increasing the range of our data will also improve the quality of our data. Then moving on to C, the student is showing a table of the results, and it says that the data validates the relationship between the pressure and the volume. What is the relation? Is the Boyle's law that's saying that P1 V1 is equal to P2 V2, or pretty much any change in the pressure and the equivalent volume should always be a constant value. So how can we justify this? How can we evaluate whether this is right or wrong? Then we have to do this calculation. So we have to multiply the pressure and the volume and see what this gives us. So this is all the results we got. Now, are these the same? We can see that the highlighted ones are exactly the same. So these two results here, they can actually prove the relationship between the pressure and the volume. And it's asking us to use data from the table, so we need to mention those data in our answer. But in general, as a general comment, if you have a look at the results of all the calculations, they are very close to each other. And since this is an experiment, there's always a bit of experimental error. So we're not really expecting our results to be 100% the same. So because of the small errors, like the change in the temperature and a bit of friction and everything, we are expecting to have a bit of variation in our results, right? Now, you can see here the differences between each calculation is tiny comparing to the magnitude. So if we had 5,000 as one calculation and then 27,000 in another one, yes, these two are way different to each other. But if you have 5,000 and then 5,005 or 5,010 or 40 or whatever, the changes between these are tiny. So we can say that those changes are within what we call the experimental error. Therefore, even though they are slightly different, we can actually consider that they are the same. Therefore, the relation of pressure and volume is kind of confirmed.